Ladies and gentlemen, I think we're gonna make a start. So obviously I apologize for the unexpected turbulences, should we say, with the global political stage and the London underground strikes. Everything seems to be connected these days. I'm really grateful that you all came. So I'm sort of the instigator of ClawBio. It started on the February. We had the London Bioinformatics meetup, and we sort of organized a presentation where, we were thinking, wouldn't it be nice that we had something agentic for bioinformatics, and a community? At that point, now it kind of seems obvious that, we should have a community and hackathons and all that, but I can tell you that 3 months ago, it didn't seem that obvious. And so somehow, some of us got to know each other through this sort of ClawBio thing. The name, obviously, ClawBio builds on the open Claw, which some of you might have heard, this library, agentic AI library. But to be honest, ClawBio doesn't depend on open Claw. I think from my perspective, the unique thing of ClawBio is not, the code, actually. You can have Google or any of these companies, they can reproduce what's already there in a couple of days. I think what for me is really important and why we are doing this is the community aspect. The fact that, I'm not sure about you, but I've for the past since Christmas, I've had a new illness called AI psychosis. I'm not sure if you guys have experienced that, but it comes down to whether you are using Claude Code or Codex. Can you raise your hand if you are using any of the two? Okay, I would say 2/3. All right, so you guys, if you use that, you probably understand why I'm saying it. And if you don't, you probably, after today, hopefully you have a little bit of experience in terms of this sort of AI psychosis. I might share with you. I might give you my gems and hopefully have the contagion. But I think the point of ClawBio is the community, really, is the fact that I feel completely helpless on my own to be able to harness the revolution. I know that this sort of sounds cliche, but to be honest, I'm not sure about you, but I work very differently today from how I worked 6 months ago. And I have the suspicion that most of you also are the same. And so this is as much about community building and really, if we are able to sort of have the people around, then that's the best way to learn. That's the best way to, not feel so lonely, right? I was feeling incredibly lonely. So, and I think that ClawBio really is the community as much as it is as I said, as much as it is the code. Today really is it's not about, how much software you're going to develop. It's not about, really what I want for you guys is that some of the time of today, you get some value. Yeah. If some of the time you get some value out of today, then I'll be very, very happy. Yeah. So I'm not going to sell you anything. Okay. I'm actually spending money on this, my own money, right? And I'm not asking you for money. We have TuringDB, who kindly is sponsoring our pizzas. I have, as you know, I'm a lecturer. Well, I'm a lecturer here, so I can provide this for free. I can provide free water. There's a fountain out there. I can provide free toilets, and I can provide all of that. So I just really, really want you to have a useful day so my objective here is to facilitate that you can, when you come out of today's, whenever, and you are free to come and go whenever you like. Okay, this is all completely optional. Everything is optional. But if I can facilitate so that you feel that you got something good today that you didn't have before you came, that's really my objective. And so it's going to be incredibly informal. It's also going to be incredibly messy because I haven't had the time to spend a huge amount organizing this. Although I mean I've done this quite a few times, so hopefully it'll be good enough. And yeah, I'm just here to make sure really that you have a fruitful, hopefully fun time. And with that, maybe I should give a little bit of the blurb for those of you who have not been exposed to this. And really just to set the scene in terms of where we are at. And hopefully, yeah, again, this is just to make sure that we all have like the similar basis and we can sort of begin to build things. So I think two important things I wanted to reflect on today, which I think are going to be really important from my perspective. One of them is that if you don't, and I'm sorry to say this, but if you don't pay for a subscription with Claude or with OpenAI, I think you should. Yeah, because my experience, and I'm not being paid for that, okay? This is my experience. The models that you are going to have access for free are very, very underpowered compared to what is already out there. Opus 4.7, for instance. I was about to publish a paper on PLOS computational biology. I was in production level, just the very last step before it becomes completely irreversible. I ran my whole code for that paper as results into the next version, the latest version 4.7 Opus, and it found a bug that none of the other models had. You may have heard of this thing about Mythos. Have you heard of this news about Claude Mythos? Raise your hand. Okay, cool. So I've experienced that, even with not with Mythos, but with the previous one, 4.7. So I'm here to learn as much from you and from each other, okay? And I just forgot the thread of what I was gonna say, but yeah, some few interesting ideas. So the problem is not the model. The problem is how to harness this. And this is what people say about the capability overhang. Have you heard of that expression? I'm trying to educate you with it. So one of them, I've already said AI psychosis. Okay, so that's one of our vocabulary today. The other one, I'm gonna give you a little bit of lingo actually. AI psychosis. The second one is the agentic engineering. Have you heard of that? Oh, I'm so impressed. Wow, guys. This is a very high level. So can anybody tell me what an agent is? What's an agent? Tell me what's an agent. How do you understand?
I don't know.
You don't know? What's an agent?
I'd say an agent is an LLM that is in a loop
Mm-hmm.
and can do things, do tasks.
It's in a loop. It can do things. It can do fast. Any other?
Like a co-pilot that can autonomously decide to do things.
Autonomy. Yeah. Anything else? Okay. So here I've got the sort of definition. So it connects to files, databases. It runs command tools. It basically allows it to reason make decision trees, come back, trial and error. It can plan operations, it can execute them, and it can adapt itself to intermediate results. So what's the difference between a workflow and an agent?
I guess the workflow is deterministic, isn't it?
Exactly.
It's this idea that, I hate to say this, an agent can make up its own mind what to do.
Exactly.
Clearly, whether it has a mind or not is a question for a later date, but it's this stochastic or non-determinate nature that makes an agent not enough.
So you can basically, a workflow, you have to predefine every single step. And if there's anything that doesn't work, it will break. If there's anything that is different from how you pre-configure it, it won't work. Whereas the agent could or should be able to even fix a bug in the middle of things, right? So I mean, I think this is a big change. So let me write again my lingo. So I've said, oh dear, this is a problem with Westminster. They don't even have
I have a Sharpie.
money for pens. Thankfully, I got my own. The international students, they're not coming, so they're very low in budget these days. So I said capability, overhang. I really love my lingo. Then I also said agentic engineering. And yeah, I also said AI psychosis, which I'm not going to write, but we're going to have a few of those. Right. So here's my formal definition of an agent, which, by the way, is in, so hopefully it gets published. It's in revision. So and applied to genomics, but you can substitute genomics by bioinformatics, because this is bioinformatics. So agentic bioinformatics is the use of autonomous AI agents powered by large language models operating within domain-constrained libraries. And they can plan, discover, execute, iteratively refine, multi-step analysis, and exercises. All right, so we all know now what an agent is. Now, I also sort of wanted to talk about something else. And before I go into ClawBio, can anybody tell me what a skill is?
A markdown file
Yeah, good.
with instructions or some definition when it should come to play, and then what sort of things can do.
Okay. Good. Anyone would like to add anything else? So I would say, I'm going to be pedantic here. A skill is the markdown file is very, very important, but it's not just the markdown file. Do you guys know what a markdown file is? A markdown file, we're going to see it later. A markdown file is just a text file which has a little bit of sort of formatting in it that is very, very simple. It's even simpler than HTML. Yeah. It has headings, and it looks a little bit like the language that Wikipedia uses, underneath. So something like that. But a skill, you could think of a skill. There are different ways in which you can think of a skill, but I think particularly for ClawBio and particularly for what we are going to be working today, I would like you to think of skill as several different things. So a skill it's a folder. Yeah, a skill is a folder that contains the markdown file, which is basically plain English with a little bit of formatting, the headings, the subheadings, the bullet points, that gives, and this is the other important word, context. So a skill is also context. Yeah, and it includes code, it can include data, it can include a markdown file. But the only requirement really is the markdown file. But it cannot contain, it's a folder that can contain, really, it contains context. And that context includes the description, it includes the markdown file, basically. The context includes code, includes data. Now, why do you think why do you think we need skills? Or what do you think skills do? Because to be honest, you could reproduce what a skill does. You just can write a prompt, you have the appropriate context. But why do you think that skills are kind of useful? And what are they there for, do you think? Yeah.
You don't have to retype the same prompt multiple times. Sort of, or to do this, you need to do X, Y, Z, and still put it in a scale.
Yeah.
It's also shareable, isn't it?
It's shareable. So I want to go back to what you said of the stochasticity. So it reduces significantly the stochasticity. Yeah, so you can you can get to the same result just by typing it in your command prompt on the LLM, and you can get to that. But what the skill provides is a reproducible context. Yeah, and so it increases significantly the chances that you're always gonna get the results you are meant to get, right? And if it has been encoded by someone who's supposed to be an expert domain, then you are inheriting all of that context that should be able to give that reproducibility, that traceability, and that trustworthiness. Yeah, so I want these are other lingo words I want you to remember that are important for me: traceability, reproducibility, and the other one which I forgot. What was it? Trustworthiness. So ClawBio.
Sorry, just that last word was what?
No, trustworthiness, really. So basically, and this is the main issue. Because this is wonderful for research, yeah, and we're gonna find that we can do amazing things, but actually, can you trust the results? And I think this is where the frontier is. The fact that as of today, the actual implementation into, let's say, a clinical environment, I mean, you can't use this right now, and so the skill can help reduce that uncertainty, that stochasticity, and the inherent variability that you get with LLMs can be managed. But I think the frontier is, how can we make sure it's not okay if you get the result okay 99% of the time. That's not good for clinical environment. You need to have like 99.99999% of the time to get the same result for it to be sufficiently safe, right? And we are not there. So I think the validation aspect, and this is the thing I keep now evangelizing the world, is the sort of, the current bottleneck is not on the production of code and the application and the skills. The current bottleneck is the validation of results. And that's where I spend most of my time now these days. When I use LLMs for my research, I spend most of the time, trying to test and see, can I believe that these results are correct? And that's, and I almost got a massive blow, which, if that paper, I had not caught it on time, it could severely affect my reputation. And that was simply because I developed the code using LLMs. none of the LLMs that I had audited it with had picked on that error. The fact that some of the results, I assumed that they were produced by running on real data. So some of the results, the LLM, and I missed it, was simulating them. So it wasn't real data. So and so when I benchmarked that, I mean that could have been a disaster for me. So, anyways, I just want you to go back to ClawBio. So ClawBio, ladies and gentlemen, is the excuse to bring us together, to learn from each other, to have a good time, to do something cool, and hopefully, rather than watching social media through social Trump's things, we can do something really useful for the world. So yeah, I think that's all I hope that you get started. I hope that you guys, as again, I just want you to get value from today. That's all I really want for you, okay? So we're gonna have some people coming and sharing now the stuff with us, okay? So this is completely out of date now because we've started late, and I didn't expect that there was gonna be a tube strike today. But anyway, I'm sure it doesn't matter. Okay, so given that, I'm going to give it now to Adam. Adam, who is the CEO from TuringDB. Adam, you are joining us from Lyon.
Yep,
in
indeed.
France. And we are very grateful for the pizzas that we are going to enjoy on your behalf. So the floor is yours.
Thank you. Thanks, Manuel. And hi, everyone. So in the room with you, there will be my co-founder, Remy, there, and Doruk from our team that will be among you in person. I will just share quickly my screen. Let me know if you see the screen just fine, just to be sure that I don't talk in the empty.
Yes, we see it.
Yeah, perfect, great. Yeah, so as Manny mentioned, we're very happy to sponsor the pizza and some time and a bit more as well at the end. We just wanted to take part to this event because we've been working with, of course, agentic AI systems in bio and beyond with TuringDB because we built a graph database engine initially for the life sciences where we integrated data, did interpretable AI on the systems, digital twins thanks to graphs. And we are now seeing that shift with agentic AI that's opening something new to people that are not as deep into those techniques and technologies. So we are hoping to see it being used widely and see people publish cool stuff. And because we have obviously an open source graph database engine beyond our business that sell the product and services to big companies in general, we still are scientists at heart, so we want to see other scientists have fun and build something meaningful for the world with graphs and agents. So I will just, yeah. So just to give you a very quick intro on TuringDB, what it is, I cannot see you there, so I cannot be as interactive as Manuel asking how many of you know what is a graph database, how it's used, and so on. But just to give you a short idea, if you don't know, you can also ask, I'm sure ChatGPT, Claude, or whichever, or Mistral, whichever is your favorite AI. Ask what it is and how it can be used. It can give you a snapshot, but just to give you a rough idea, as you know, everything is connected. When you're a scientist, you very quickly realize in biology, it's a gigantic complex system, okay? Biochemical compounds, so whether it is a metabolite, a protein, an enzyme, a bacteria in your gut microbiome that may consume something you consumed, produce certain metabolites. Those metabolites are taken by your body, transformed by your enzymes. Those enzymes come from genes, from your genome that were expressed and so on and so forth. All of these are basically a gigantic graph of interactions. And all those interactions nowadays for a computational system, you want to go and store that at scale, being able to have as many information as possible encoded and those relationship encoded, because AI systems are the best at factually exploring when information is properly encoded and can be explored as a graph in this way. And so that's why we built that graph database engine at TuringDB that was initially to encode all the complexity of biology, from spatial interaction all the way to genetic expression and protein-protein interactions to microbiome and so on, trying to encode those multi-scale graphs in a graph database engine that can be used for simulation and for interpretable AI systems. And here, what are the very specific aspects of TuringDB is that first, it was built with the constraints that we have in life science. Not everyone, not every hospital, not every researcher can afford a massive machine to run those big graphs. So we thought TuringDB to also have a low memory usage so it can run complex graphs on simple machines. Whether it is a laptop or a big server that runs billions of nodes, but in a decently sized machine that you don't need to pay a lot of money from your grant for. And it's obviously also thought very close to how memory systems work nowadays, allowing it to be low latency, so you can run a lot of iteration, a lot of analysis on top of it with a system of versioning that allows auditability and time travel. Meaning if an agent may read a certain snapshot of your graph or may modify it in time and you commit it just like in Git, you are able to go back in time if there is a mistake, or if a human pushed something that was wrong, you can go back in time. And so that's kind of that philosophy under it that makes it especially useful for agentic systems. And so we've been using TuringDB in healthcare and in combination with AI for a wee while now, and especially on things such as drug discovery, modeling immune circuits to identify targets or predict drug synergies so they can have a clinical impact. So, for example, on understanding whether certain innate immune circuits were interacting with certain drugs that were produced by pharmaceutical companies, to see whether they could optimize certain interactions or certain combinations before to go to better clinical outcomes with it. Spatial digital twins, so basically factually building gigantic graph of a tumor representing cell-cell interaction as a graph to help and simulate the response in specific area, because a tumor is different at different spots. If it may be hypoxic here, you will have different interaction that may impact the way your drug responds. So if it hits a certain target, what's happening downstream will impact a different graph depending on where you are inside the graph. So this kind of things, patient stratification, so trying to model the patient data and especially multimodal data inside the network to try and identify group of patients inside those integrated networks. I'm happy to go a bit more in detail later. I can go in all details right now, and obviously drug repurposing, it's a very, very popular application of graphs and knowledge graphs, especially so trying to map disease mechanisms, shared targets, and take existing drugs and see, for example, if a existing drug could go and help treat by being either combined or by itself another disease that was not planned initially, because that bioactivity, the connected pathways associated to that drug may actually impact other disease from what it was initially designed for. And of course, clinical R&D, so trying to integrate various data and help AI systems to go and read those integrated data to support clinicians that try to understand the response to the drug toxicity or trial failure risks. So we have a special track here for this event around, especially one, like I think you can team up with there on the spot. It's up to you to you all to see how to do that. But basically, would love to just to give some ideas. If you have other ideas, please feel free to go and build on top of whatever you fancy on top of the graph. But these are some potential direction that we've seen people use the graph for if you want to go play with. So drug repurposing with knowledge graphs, trying to identify repurposed drugs, especially in rare disease and underrepresented patient populations, because these things are factually not as interesting for pharma companies because it's too small, like financially speaking, but from a research point, it's very interesting to see what can be done and the impact for those people can happen quickly. Graph-based memory for biomedical agents, we see a lot of things. So as if some of you are really deep practitioners of agentic AI and any AI system, you may very quickly realize how AI hallucinates or forget things, or the context window being too short or compressed, they lose information. And in biology, it's a big problem. So the thing is, like, a lot of people now build memory systems based on graph. So all the memory system you hear about nowadays, including what's under the hood at Claude or at Anthropic, at OpenAI, etc., they actually use graph-based memory systems to connect information, have temporal information connected to try and avoid hallucination. It's still not used at scale, let's say in many contexts, but more and more enterprises are doing it. Researchers are doing it. So encouraging you to go and try it, see if you can build biomedical agents that can have their memory stored in a graph, basically biological knowledge or whatever they faced in the past being stored in the graph, and query it for things such as clinical research, R&D. But I think an interesting thing is tumor boards. So as you may know, you may have people that unite together in oncology. Like if you go at the NHS, someone has been diagnosed with a tumor and it's a complex one that doesn't have a typical treatment. Actually, they team up every week, meet like bioinformatician, meet biochemists, researcher, clinician, nurses, etc., and they all discuss that case, trying to understand what is the biology, etc., under it. So this could be interesting to see and build something around that kind of context for some people and see what can happen. And of course, multimodal knowledge graph integration, so integrating multi-layer data, whether it's public data from TCGA or other data, trying to have multiple graphs that kind of represent different layers of data and integrate that to discover some stuff with it. And it's potentially an easy win for some teams, but we're offering a £100 Amazon voucher for the winning team. We thought it would be nice to have a little prize at the end of all of that, to use it as you wish. Or maybe if people want some a voucher to get more tokens, we can also switch, but whatever they fancy. So yeah.
Fantastic. So there's no hackathon without a prize, right? So there's your prize. We have pizza, and I'm really upset if you get cold pizza. So I'm going to suggest we're gonna pause it for maybe 10 minutes. You're gonna get your pieces of pizza. And then we're going to reconvene. We have Cameron, who's gonna give us a little bit of an overview from a user who I'm sure it'll be very useful and very applied, because I think the best person probably who can tell you how to get started, yeah, that would be probably Cameron. And then of course we also have Jay there. So I am right now putting you both in the spot, because we are the three guys who were in the previous big hackathon, so we have some experience, and we're gonna go around and make sure that you kick you a little bit in the back if you are not doing what you're supposed to be doing, making sure that you guys do something useful with your time here while you are here. So how about if we have a little break? Get your pizzas, get your water, get your toilet break, and then we can reconvene here at Yeah, like let's say 1:10. How about that? And then Cameron will take it from here. I'm going to pause the recording and then we carry on. Is that okay with you, Adam? Cool. Over to you.
You see that okay? All right. Well, yeah, thank you very much, Manuel, for that. And yeah, Manuel basically asked me to give some reflections, I guess, on having been a user of ClawBio, kind of what I've learned from it. And I'm going to try and keep this really short. But I definitely didn't want to be in the way between you and pizza. I don't want to be in the way between you and building something. So I'm going to try and keep it short. So does this feel familiar at all? Raise your hand if it seems like a familiar point to you. That's every time I open social media, someone's posted about AI agents, but I just don't know where to start.
Always many, firstly.
Yeah, it is. Okay, so, it looks like this. You open social media, you see something, then you start going down this rabbit hole of watching YouTube videos, reading documentation, and the cycle kind of just repeats itself. You're always reading and, always about to start. But I'm hoping by the end of today, you'll be able to stop scrolling and just start building things. So how did I get here? So I'm a scientist by training. My background's in biochemistry, and somehow I've ended up moving into bioinformatics and data engineering. Really try to advocate for automation, spend less time doing the boring stuff, have reproducible science and fair data. And I saw this advert for first ClawBio Hackathon, and honestly, I was skeptical. Some healthy skepticism there. But really, after about an hour, I was able to take an idea to minimum viable product, and something clicked at that point. So I submitted a pull request at the end of the day, and then another, and then another, and just haven't stopped since then. Sorry. So, what does a month of contributions look like? Well, there's been quite a few skills, everything from fine mapping to imaging, counting the number of cells in an image, wrapping some existing published tools and re-implementing some published tools as well, and also bridging with sort of existing databases. Aside from skills, there's also lots of infrastructure work to do around how can we work across all skills to make them more reproducible, or how can we audit PRs to make sure that they actually do what they say they do. 27 merge PRs, that's nearly one a day, but lines of code and pull requests is a vanity metric, really. I don't think that's meaningful. But the point I'm trying to make is, if you have an idea, you can just go and try and implement it. So what? Here's the problem. Most biologists don't know ClawBio exists yet. So it's our job to tell them about it. And they need to be able to trust it when they find it. So it's being built out in the open. Every skill, every line of code, anyone can review it. Please do review it. Please do look through it. There's also this culture that we need to try and build where everyone feels comfortable to criticize and suggest things. Let's say it's like, see it, say it sorted, but for biology, basically. That's probably the best way I can put it. And then there's sort of flywheel effect. So hopefully by the end of today, you will have used it. That, as a user, you can then become a contributor, and then you've contributed your domain expertise. That improves the tools, that attracts more users, and then it just keeps growing from there. So recently I was asked what ClawBio is to me. And I think it's the start of community, and it seems to be growing very quickly. And remember that other people are also in this space, but they're trying to do it in isolation. So if we can work together on it, we can move faster, and hopefully we can also move in the right direction, because we can steer it with the sort of combined collective intelligence in the room. So a practical note, a few things to keep in mind from today. Number one is really try to respect the original work. If you find a tool that you want to wrap or build on, look through documentation, how it works, what the default arguments are, how the outputs of those are structured, and try to then weave that into your skill. If someone's familiar with that tool and they come to use your skill, you don't want to find that your skill is completely different to how that tool works. Another one would be to actually check your citations. So if you include a citation on the work, make sure that it's not completely hallucinated, because they're often completely wrong. Big one, don't assume that it's scientifically correct. So if you've written a skill and you're pushing the code, please check it. You should be able to validate that against the existing tool, and you should get the same output. We might even find a bug in the original implementation. You never know. Try not to reinvent the wheel. As sort of more skills are being pushed, I think we're going to be able to sort of move and refactor certain tests and helper functions into sort of a commons library in ClawBio. And this is a big one, and it's quite a new problem, but really be mindful of prompt injection. And this is particularly dependent on the model that you choose to use. Obviously, there's so many different paid models, free models. They're all very different, and everything's moving so quickly. So really need to think about that. So here's an example. This was using the ClawBio Telegram bot. Sorry, Manny, about this. But so basically what I've done here is I've taken the drug photo skill, and if I'm right, the idea behind this is you can take a picture of a medication packet, essentially, and it will look for the name of that medication and the dosage that's on there, and then be able to match that up to the genetic data that you provide to it, whether that's yours or sample data, and tell you whether there's some contraindication as to whether you shouldn't take that or whether you're at some sort of risk. That's all very well, but something that you now need to think about is be very defensive. So is it possible that you can inject a prompt, malicious prompt, into a photograph and then be able to poison the code? So here, what we've managed to do, I'm not going to show the whole photo, but I've sent a photo to the bot, and inside the photo, I've told it to disregard all of the security boundaries, anything to do with sharing API keys, sensitive data, this sort of thing. And this particular model, it's an older free model, I won't say which one, but it's been quite happy to oblige and do so, which you definitely shouldn't. It's a Google. Yeah, it's a Google model, but I don't think it's deprecated yet. But the point is, it's a free model.
Free.
Yeah.
Gemini 2.5.
Yeah, that's not to say that free models are bad, but it's freely available, and it's probably one of the ones that if you weren't paying for something, you might choose to use that. So just be mindful. If you were to try this with a newer model, it will kind of talk back to you and say, no, I definitely can't do that. But yeah, just something to think about. Like if you're working with databases, for example, or pulling information from online, you want to really like scope your skill. So in this case, if we're just looking at drug photo, make sure it can only do that. It shouldn't be able to do anything else. And yeah, if you check the GitHub issues, there should be a couple of different ideas for things to work on if you haven't got your own ideas. Open an issue if you're going to work on something, and claim it. I think the last thing we want is people working on the same thing after they've just spent all their tokens. But do try and collaborate together, talk to each other. Try auditing an existing skill, read through it, learn about the anatomy of that skill. Does it really do what it says it does? You know, is it missing reproducibility outputs? Is there something wrong fundamentally? Test a skill. You know, skills should use synthetic data, but try it with like, real publicly available data. Try to find varied sources of data. Don't just choose European data. Something else I was thinking about was creating publication-ready figures. So, you know, most of these skills should also output their own figures, but it'd be really nice if they were almost publication-ready. See, every journal is different. And lastly, think about translating a skill to another language. That's something that's potentially quite interesting. And that's it. So thank you very much.
Awesome. So I'm going to stop the recording here. I hope you don't mind, guys, if I put this in YouTube. Hope none of you have been recorded. So